Good morning, everyone. My name is Pam Bold. I'm the Executive Director of the High Sierra Energy Foundation, and the High Sierra Energy Foundation is a member of the Central California Rural Regional Energy Network. We here at High Sierra take the lead on the Codes and Standards program, and wanted to give you a little bit of background on what a regional energy network is. So regional energy networks are a framework for local governments and nonprofits to work on designing and implementing programs specifically in their community. These are CPUC funded programs based on ratepayer funds. And our Central California Rural RIN, or CCR RIN, as you'll see, is really focused on hard to reach customers as well as disadvantaged and underserved communities. Next slide. So this is the region here with 14 counties. There are 96 AHJs, authorities having jurisdiction in that region. So there's a lot of them, and we're doing our best to get out to each of the AHJs to provide information about these types of training, as well as some code coach training that we'll talk about a little bit more. But the leadership is, the RIN is administered by the County of San Luis Obispo. It includes AMBAG, which is the Association of Monterey Bay Area Governments, San Joaquin Valley Clean Energy Organization, High Sierra Energy Foundation, and then the County of Ventura is in an advisory role as they are also a participant in the 3C RIN. So next slide. So today we are pleased to have Inbalance Green Consulting do this training on heat pumps in cold climates. This one is near and dear to us here in High Sierra region. There are some differences, and so Jennifer and Grant are joining us today and have spent some time really fleshing out what some of those differences are. And we open this conversation, there are people here in high country cold climates that are doing this work on a regular basis. And so we also would love to hear from you, things that work and don't work, or that you maybe have concerns with. But I'm going to turn it over to Jennifer now and take it away.
Oh, thanks, Pam. Welcome, everybody. I'm glad you could join us. Like Pam said, I wear a couple different hats, and one of them is with Inbalance Green Consulting. And we provide a lot of different services, including being an education provider and an energy code coach. And through the CCR RIN's Codes and Standards program, we do like online training like this. We also do in-person training for various jurisdictions that request it. We will cover specialized topics. We've consulted on a few of the ADUs that are part of the county's effort to have, free or low cost permitting ADU pre-approved plans. And we have a lot of questions, let's say. So speaking of that, the questions that come up, Energy Code Coach is open to architects and designers for sure, builders, yes, project owners. So sometimes, homeowners will call us, but lately we've been getting a lot of questions from the folks that are in the jurisdictions themselves, the plans examiners, inspectors, sometimes guys who are out in the field and are starting to see, the implementation of the new code for heat pumps, heat pump water heaters, which is what we're going to talk a little bit about today. So this is free to everybody. It's part of what the RIN offers as a service. Each of us pays a little bit of money on our electric bill, and that goes back into providing education to all of us. So it's easy. You fill a form out online, and then a code coach, typically Grant, who's on our call, will follow up with you and get the question answered. And so some of the common questions we get with Code Coach service is could be simple stuff like, how do I get my Title 24 energy code report registered? We also can address Cal Green, accessible EV charging. We had Ventura County, for example, tap into this because they were increasing their electric vehicle access and charging, and local private businesses were wondering about that. And then a lot of questions we get lately is, what are my options for hot water other than a heat pump water heater? And let's say, okay, I go with that heat pump water heater. That's what my energy consultant is telling me is on the plans. And then we get questions about like, well, how much space do I need for that heat pump water heater, etc. So this course is available for learning units. If you're AIA architect, you get one. If you're part of the ICC, you get your 0.1 CEU. And after this, you'll get a copy of the slides. Briefly, we're going to hit on some of the California Energy Code goals and touch a little bit on California climate zones, because that's key to what we're talking about for cold climate heat pumps. And then we'll dive in a little bit about space conditioning heat pumps for cold climates, and then considerations for heat pump water heaters in the cold climates. And then we'll do a little wrap up and a couple of resources for you with the links. All right, the Energy Code has been in place since the late 1970s in California. And it's just part of California's overall goal to have more cost-effective, energy-saving construction. And so these codes have been updated approximately every 3 years. And through that effort, the 2025 code that's coming into effect now is estimated to provide a $4.8 billion in statewide energy cost savings. And part of how they calculate that in is they're looking into when we do these energy savings measures, yes, it helps save the customer's energy and operational costs, but also it keeps our state from not needing to build expensive fossil fuel burning power plants. And it also helps provide a cleaner grid. So that's part of the reason that California in the Energy Code has been moving more and more towards all electric technology and all electric new construction. So it doesn't mean you can't use propane, natural gas, etc. in your buildings. It just means that now with the technology of heat pumps that's been around for decades, although it still seems relatively new to a lot of folks in California, this has been around for many, many years and vetted in Europe, Canada, and countries south of us, and in Asia, and various locations. So the heat pump space heating is a new baseline for your Title 24 energy report. And heat pump water heaters are also the new baseline. So gas appliances can be used, but you have to use what's called a performance energy model just to show that your overall building still won't use any more energy than a like building that uses heat pumps. And part of that package, it also includes energy heat recovery ventilation systems for balanced ventilation. And we'll touch on that for a couple slides if you're not familiar with what it is, but it allows you to bring fresh outside air into your building, and it tempers that air coming into the building so that you're not introducing extremely cold air when you do get fresh air into your building. California has a lot of microclimates. And as a result, when the Energy Code was first being implemented, a lot of smart people that did a lot of scientific research and really looking at California, building energy use, et cetera, they realized that we need to break California up into various climate zones because one solution doesn't fit all of California. And they came up with 16 climate zones, but you'll find out today, even within that, there's a lot of microclimate difference. Yeah, was there a question or a comment? Okay, maybe it's just I'm hearing something here in the office. But anyhow, through California Energy Commission, you can use an called their Easy Building Climate Zone Finder. So if you're not sure what climate zone your project is in, this is a good way to find it. And then if you go to the joint appendices, JA2, as part of the codes and standards for Title 24, Part 6, that reference appendice book that goes along with the standards, you will find some weather climate data. And I took an excerpt from a paper version, not a digital version, and then we'll walk through that later on to show you what that's all about. Now, within our tri-county, within actually all the RENs, but the CCR rural REN territory, we have 3 groupings: Central Coast, San Joaquin, and the Eastern Sierra. And within those 3 groups, they each are comprised of different climate zones. So the Eastern Sierra is mostly comprised of climate zone 14 and 16, although there's some 15 that creeps up in there. And then the San Joaquin Valley, we've got climate zones 12, 13, 14, etc. So these climate zones are quite varied in their needs. So this today, most of the things we're talking about, it's really going to be a little bit of the San Joaquin area and mostly the Eastern Sierra climate zones. Primarily 16 is what we're talking about today, because that's our coldest climate zone in California. Okay, with that said, I'm going to jump into a little bit about heat pumps themselves and kind of start to talk about the heat pumps, and then we'll run through some examples, take a look at how the heat pumps might perform in certain situations, and then we'll move into some heat pump water heater kind of applications. Grant, feel free to jump in at any point. If I miss something, same with Pam. The two of them, it's sometimes it is nicer to have more of a dialogue. And also if there's a question for anybody, please put it in there. And also if you have expertise in this and there's something you think is really important that the rest of us should know about, or if you have some insider information on any of this, put it in the chat. Feel free to join the conversation, because a lot of times we find these classes, it's really helpful for the other folks who are on the class to meet each other and get to know each other and find out what's happening. Okay, with that said, I have to do a super quick pause and plug in my computer. So I'm going to disappear for a second. Grant, would you like to talk about this slide while I do that?
I'm sure everyone's familiar with these ductless splits that she's got shown here. The conversation we always start with is like, hey, what are heat pumps? Is pointing out that we see heat pumps all the time. And the first explanation is always your refrigerator. A lot of new cars use heat pumps. The idea is that you're transferring energy, either that heat or cool, into or out of the home, rather than generating the heat by burning a fossil fuel. So just getting everyone aware that, by moving it, the other location is going to be exhausting the opposite heat. So your fridge puts off heat to cool the inside. These heat pumps do the same thing. Um, Connected by a conduit line, you can see designated running across the wall there out to the outdoor condenser. A lot of the conversations we have is about the location of these, the space requirements. These are the typical split system. So locating that condenser, locating that indoor unit, what type of indoor units, um, that's what we're kind of saying there. I know a lot of this is going to be discussed about the negative outdoor temps, but I'm sure Jennifer has more slides on that.
I do. And a lot of folks, a lot of people, they don't realize that there's still heat in the air, even when it's extremely cold outside. And with the new, kind of newer, better, improved heat pump technology, we have equipment that can capitalize on that and pull heat out of the air, even when it's well below freezing. And some of the common kind of split system heat pump types, and this is what we'll be talking about today. We have ductless systems, which seem really appropriate for cold climates because you don't have the extra heat loss through the duct systems. And then we have cold climate rated ducted systems that sometimes the outdoor unit looks a little more like a traditional kind of air conditioner, but it's a high efficiency heat pump. And then we have, also systems that are the more thin, narrower profile that's very common to see in Europe and other parts of California. And a lot of these are rated for cold climates by Energy Star, and that is something that we want to keep in mind as we're going through the slide deck. Also, kind of new to the Energy Code for 2025 is some definitions that have come up, and that's because these types of systems are becoming more popular. These types, I mean heat pump systems, and so to kind of differentiate what we're talking about, this is an example of a split hydronic system where the primary purpose is to generate heat to heat your hot water. And this is a Sanco 2 system. This system can be used in extremely cold climates, and it's operational to minus 26 degrees. There is a specialized freeze protection kind of algorithm kit that you put with it, like a specialized pan that heats the bottom so the bottom doesn't ice up from the condensate, etc. The pipes need to be well insulated you'll have to get the heat tape kit. You want to use really good insulation, pipe sleevings recommended, and specialized valves to protect the unit from freezing. But that's all part of the package when you know that you're going to be in a cold climate. And the tanks of hot water would be indoors, not outside, like this project, which was closer, much closer to where I live on the west coast of California. So these exist, and it's possible to use this kind of a system in cold climates, freezing temperatures. And then this brand, for example, has been incorporated to Harvest thermal system to also provide space heating. Then the other kind of type of heat pumps we're seeing that we can refer to is air to water heat pump. It's really similar, but in that it's air source. We are heating water, but in this case, the primary purpose of this type of heat pump is to already, not with an added kit, but to already be able to generate heat for your domestic hot water and your space conditioning needs. And then, for example, the Space Pack Solstice, like this unit's designed to be operational to below 22 degrees Fahrenheit also. And again, it's all part of the system. When you know you're going to be in a cold climate, it comes with all the other aspects to protect from the pipes from freezing.
On those
But yeah,
those monoblock systems, there aren't many on the market. Where these are an up and coming type of technology that we expect to see a lot more of soon. There's conversation about them about quantity of refrigerant required for systems, which is a whole different discussion. We've done trainings on it in the past. If you're interested in that, we'll start seeing these soon.
yeah. And with both of these systems that we just showed you, the idea is that you have a small amount of refrigerant in the outdoor condensing unit itself. And then now you're able to use water with your freeze protection kits to transfer that heat into the building and to reduce the use of refrigerant. Okay, so when it really comes down to looking at what it takes for space conditioning, for heat pumps and cold climates, there's kind of three main things to understand. If you're already in the engineering side of things, maybe this is kind of obvious, but to like homeowners and even sometimes a lot of plans examiners who do this work, and especially like the building owners and maybe even some of the folks doing the building, they don't really quite understand that first step is to understand the microclimate that the project's in, including elevation. And that's key for our climate zone 16, because there's a big variety within climate zone 16. And then the equipment itself is supposed to be sized using an approved method such as ACA, ASHRAE, and the engineer or the installing contractor needs to provide the method for and show how they size the equipment to really meet the needs of the project. And then the third thing is really to verify that that proposed heat pump will meet the load profile of the space and any other additional design criteria, such as pipe freeze protection or, other aspects like that. So when it comes to understanding that microclimate, that's where you can use Appendix, the JA, the reference weather climate data. You can also pull the nuanced data within ACA and the manuals. They provide that, and ASHRAE provides that. And then in some cases, like Mammoth Lakes, I see someone here from Mammoth area, the city has provided what those design criteria are going to be. And then for the calculations themselves, we're not going to really go into how those are done, because that's a whole nother class or two or three or four. But in general, it does require that you look at your floor layout, you look at what the internal gains and losses are within the house, like how is that house being used or building. Does require looking at the air leakage through those construction assemblies, whether it's a tight house or a very leaky house. And then the ducted systems themselves, the ducts need to be designed for residents per like ACA Manual D or other method. Commercial building, you could use the ASHRAE standards and use ASHRAE system for designing it. A lot of times that isn't done by everybody who comes out to work or install heating and cooling equipment. So if you're a homeowner or your jurisdiction, you should be seeing this, especially for cold climates. And it is actually part of the Energy Code's residential mandatory measures requirements that the building and heating loads be determined by methods utilizing ASHRAE, ACA, etc. So taking just kind of a excerpt from the climatic design data from the joint appendices, These are just some examples of climate zone 16. And this is like a window into the kind of stuff that the engineers and energy consultants, Grant and I, deal with. But it's, I think, a good idea for other folks to see what goes into it. All this examples here, the cities are all climate zone 16. And then today, the things we're really going to be worried about is what goes into heating. And there's something called a winter median of extremes. You could use that. It's also okay to use the 99 point something or 99% data. In other words, with the median of extremes, they're going to look at the coldest extreme temperatures throughout about 30 years of data of which were those coldest, and then take that middle number. It's not necessarily an average, but the most common middle point of those extremes. And then for Blue Canyon, which is not in our CCR-REN territory, but Blue Canyon is what's used as kind of the base climate for climate zone 16. And that winter median extremes is 13 degrees. And then the other design data would be 20, 24, meaning most of the time it's good, your temperatures are going to be in the 20s in the winter and not even in the teens for that. And the heating degree days gives us an idea of how much heat is needed throughout the year. And so over 5,000, that's a good amount of heat. But the CCR-REN, Inyo, Mono County areas, and the kind of the up in the Sierras and part of both those counties, we have a really big difference in climates. And so elevation comes into play with the heat pumps. And take Bishop, and we're at 5 degrees median temperature, not so many heating degree days, although we have a lower design temperature. So that's kind of interesting. Mono Lake, we have about the same kind of design temperatures, but we have almost 2,000 or just over 2,000 more heating degree days. So we definitely have a more continuous need for heat in Mono Lake. But now take a look at those other towns, other communities that are part of this region, like Bodie, Bridgeport, Boca, and now our winter median of extremes is in the negatives. You know, that's like a 30 degree span right there between the kind of the base climate for climate zone 16 and then the other communities that are in our CC-REN territory. So this comes into place really when these systems are sized. So if you're working with an installing contractor, your engineer, you want to know that they're actually paying attention to your unique location. And then for places like Mammoth Lakes, for example, they did by local ordinance kind of state what the design winter temperatures will be, because Mammoth Lakes isn't actually listed in the climatic data. So for some other locations, you might be close enough. You might know what you should use, but with Mammoth Lakes, they went ahead and put it in an ordinance. So we're going to use an example of the outbound Mammoth Villa that installed heat pumps. And we're going to kind of run through an example of what that might look like. And then I see there's a question in there, Grant. I just saw it pop up.
Yeah, I'll handle the chat
Okay.
portion of it. We can talk about it again.
Okay, that sounds good.
There was a follow-up one that I didn't see. Will the standard design change based on what city you input, or is climate zone 16 always based off that baseline city?
Go ahead. Go ahead.
When you select the city, depending on what software, well, all the softwares, but when you're doing load calcs or compliance, when you pick the city, it will tie the climate zone to it. So the climate zone is what sets all your baseline requirements, what you're compared against, etc. They just make it easier so you don't have to memorize the climate zones when using those softwares.
And what it does is it will take that kind of, it'll take, there's something called TMY2, TMY3 data, typical meteorological year data that spans over like the 30 years I was talking about. And so they'll take that kind of profile for that base city, and then they'll modify it to fit this other climatic data to create a new weather file that's running in the background. So it does take into account those extreme design temperatures when you choose the appropriate city. But interesting point, because sometimes that can really change the results of people's calculations if they aren't choosing their location or, properly. Because that's a, big difference if you just go with like the generic Blue Canyon versus doing something custom for Mammoth Lakes with the -2 degree Fahrenheit design temperature and realizing that you're going to be dealing with like 8,000 heating degree days. But with that said, let's go into an example of how we can kind of double check that. So this example that is there locally where they installed Samsung heat pump space heating systems. And by the way, we're brand agnostic, but you will see a few brands of products here because either that's what's available in our area or it was installed on a project we worked on or that we're looking at. And I have pictures of those things. And we also just want to use an example, but there's a lot of brands now of heat pumps available. We could go through a list of those a little bit later, but this particular Samsung unit has a guaranteed operation down to -13 degrees Fahrenheit. It is cold climate certified, and there is integrated 150-watt pan heaters with specialized operational controls that go with it. This particular one installed optional wind baffles, and it's raised a bit and recessed to protect it from the weather. The refrigerant lines that go to the ductless units inside are insulated. And then to further kind of protect it or visually screen, there's an offset panel in front that gives everything a clean look. And then if you aren't, up in native to Mammoth Lakes and want to look at it, which I did, I went on to Google Maps, typed it in. And so I was like, oh, that looks pretty good in the picture. So I clipped that in there for you. But otherwise, I relied on the photos that Pam got for me. And, it looks good. And from what I gather, the project's working well. And one key thing about this is that the project was really, those heat pump systems were actually designed for cold climate. So one of the things you can do is if you're in a cold climate and like as a homeowner or someone else who's not the engineer on the project, you can ask specifically to make sure that your products being installed are rated for cold climate. So that'll give you some reassurance that the heat pump system will be appropriate for your location and work. They are variable speed compressors. I'll make all of them that are rated for cold climate. They have high efficiency. And the most significant part is that to be able to qualify for the Energy Star cold climate certification program is that at 5 degrees Fahrenheit, they're guaranteed to have operational capacity that is 70% or greater than the capacity rated at 47 degrees Fahrenheit. And the coefficient of performance, the COP at that 5 degrees, has to be at least 1.0 1.75 or greater. Most of them I've noticed are like around 1.8 to 1.9 and 2 and 2.1 COP. And COP is coefficient of performance. It means 1 unit of energy goes into creating the heat, but you get 1 to 2, 1.75 or 2, which these cases is you get 2 units of heat back. So even at 5 degrees. And then they have specialized controls, and the manufacturer has to prove that the control system will, in all the tests they do, will operate that way as it would in an actual customer's home. So there's no test results that the idea is not to tweak it so it performs well in the test, but when it's actually installed, doesn't work that way. So that's another reassurance for a cold climate rated or certified heat pump. So this heat pump that was installed, this is a great website if you're not familiar with it. This is a Northeast Energy Efficiency Partnership website because they have a database for cold climate air source heat pumps. So yay, cold climate East Coast, Northeast has put some effort into this, but we here in where it is cold in California can tap into this database and get a lot of useful information. So if you go there, you could pull up this unit along with many others. And so I pulled up that Samsung unit to take a look at it, and it's AHRI certified, which, as an energy consultant, this is the data I need to do my analysis. So I can pull that data up at the AHRI website, and that's Air Conditioning, Heating, Refrigeration Institute. And then it lists, and the data is also in the other table, but this gives me, what I need to show that it's AHR rated to complete the assignment, so to speak, for the energy consultant and our HERS or ECC rater. So gives us the efficiencies and the capacities at the 47 degree Fahrenheit mark and at the 17 degree Fahrenheit mark, and those two data points is really what Title 24 uses. But what's more important to a lot of us who are helping to size these systems is we really want to know, well, what's it doing at like 5 degrees Fahrenheit? And also, what is it doing at temperatures even colder than that? So a great feature of this website is you can pull the data from the manufacturer, and they've put it into either a graphic like this or into a chart form, and it gives you an idea of how the system might perform in its upper boundary when it's running at its highest capacity, and then where that performance will be when it's just running at its more energy efficient sometimes, but lower capacity range. The data point, for the 47 degree Fahrenheit is kind of these bright red dots, and at 17, that's what's it's rated there. Those are the two data points that we get when we're looking at this for Title 24. The Title 24 Part 6 energy modeling gives us an idea of how much energy your building will use, but when we look at the loads, we're only getting these two data points, and it's not always appropriate for cold climates. It works great way out here on the West Coast and, along the South Coast of California, but not so much where it's cold. And the heat pump, it's going to operate between this upper boundary and this lower boundary. And it will modulate and go up and down and use very sophisticated controls and be able to release the refrigerant through the system. this controller valves work so quickly. Many, the right word for it, without getting too much in the weed, it could just meter out the refrigerant as needed in microseconds. And so they're very sophisticated, but the actual performance is going to be somewhere between these boundaries. The lines are dotted because these are not hard and fast performance. It's actually more blurry. And the performance of a building itself is going to hopefully lie somewhere in between. Now, what's more interesting for us is what's the performance at 5 degrees, but also what's the performance at negative 13 degrees. For this project, Mammoth Lakes, let's say, for example, we're looking at our median of extremes design temperature, and let's say that it ends up being about 20,000 BTU load for that one portion of that fourplex that we were looking at. Okay, so it's like, okay, great, that's falling in between this upper boundary, lower boundary, and then we could take a look at maybe a representative load profile. Although again, I get to caution you that homes don't follow a linear course. They're it really depends on what's going on inside. Did people leave all the windows open? Is it a sunny day? Has it been cloudy for days on end? That'll impact this load profile. But the idea is that there's enough cushion for when those temperatures do go down below even the -2 degrees, that there's some cushion in the capacity of the heat pump to cover those loads. And then just kind of as a reminder, as that outdoor temperature drops, the need for heat increases, but at the same time, the capacity of your heating equipment is dropping. So you want to find the happy medium where all of the needs of your building are being met by the heat pump you pick up. Okay, that makes a lot of sense. And it was probably, a good choice for that project. And just, full disclaimer, I wasn't involved in that project, so I'm kind of backing into it, but this is the similar process. And we can take a look at it that way. Now, when it comes to, this is new construction. When it comes to looking at, well, what would you do of a house that's already in existing, then we're going to look at some different options and some different considerations. But before we do that, was there any questions on that?
There were a couple questions. I answered most of them.
Okay.
But I think they're worthy to go over again at the end, and we can just
Okay.
run through them all. I'll keep going
Okay.
for now.
Okay, very good. So when it comes to the heat pumps for an existing project, we want to look at what's already there. What kind of fuel do you have? What's the cost of electricity? Or is this a repair you're working on, or urgent replacement? Or is it part of a larger home improvement project where you're planning to upgrade the windows or increase insulation or add an continuous layer of R5 insulation on your roof, for example, or R10, for example, and do air sealing? All those will have an impact on what decision you make for your heat pump. So this example here is a project taken from a project process that I just recently went through, and for fun, I took the house I was working on and I put it into the Bishop climate just to see what it would do. And so this heat pump was a heat pump that was totally appropriate for the milder climates. And I wondered, what was this profile like? What would it look like if I moved this house to Bishop? And so I looked at, I got my 2 data points, 47, 17 degrees, here where I'm located currently. If the heat pump works at 17 degrees and meets the load, I'm golden. But what does that mean for Bishop? And this might also work for like what those temperatures we saw like in Blue Canyon. But this isn't going to really work for Bishop, where I needed to look at the load profile at 5 degrees. And it turns out it was like around 26 kBTU. And this unit's only going to be providing 25. So at 5. So it's not meeting it. And then, this was kind of representative when I spot checked some loads on that. And so I definitely am thinking, wow, with Bishop, we're also going to have temperatures that will get below 5. And the heat pump doesn't quit working. It's just that now its capacity is diminished. But remember, as the temperature drops, my need for heat increases. So now I'm getting this gap of where the house profile definitely isn't being met by the ability for this unit to function. So if I were to use this kind of a heat pump, I would definitely need to still have backup heating for these cold climates. Now, I said, okay, let's see. Let's take a look at Mitsubishi's cold climate certified heat pump, same line, same, nominal 36 kBTU unit. What's that going to look like? Well, yeah, the unit does get bigger. Same profile on the building loads, but now we have this upper capacity range where it's, and they're looking at it, what can it do at negative 13 degrees even? And so now I would start to get a handle that this unit would be more appropriate for the cold climates and could meet the loads of the building. So that upper boundary is high enough that the equipment can modulate within that zone and meet the needs of the residents. Knowing, again, the resident isn't going to follow that strict line. It's also going to be up and down, but it would bounce within that range. So that gives you kind of an idea of how important it is to really see what equipment's being used and is it appropriate for cold climate. For a dual fuel situation, a lot of times this comes up when the house already exists, which is this case, and they already had a gas furnace. They didn't have a heat pump that provided heating. It was time to replace the furnace, so they opted now to use, and they had Carrier brand, so they opted to put in a more higher efficiency gas furnace and then include the heat pump outdoors. And part of their motivation was to just reduce their dependency on fossil fuels. And they were looking into getting solar to supplement their additional electric use. And then since then, kind of as a sidebar, Carrier has variable speed capacity, also Energy Star cold climate certified down to negative 13 degrees. When it comes to the cost of operation, it's sometimes tricky to figure out what you can expect, but if you're in Southern California Edison territory and you do install heat pump or have battery or EV charging, you can move to their time of use D-prime plan. So if, for example, you were using energy, the average, all your energy was used evenly throughout the day, that would average about a 31 cents per kilowatt hour virtual rate. And then just to kind of give you a sense of how to look at that, at $3 a gallon for propane, using a 12% rule of thumb, you convert that back to electricity, and it's would be 36 cents a kilowatt hour. It's not that you're paying 36 cents a kilowatt hour, is that it's that it gives you an idea of a cost kind of energy comparison. So in this case, moving to a heat pump could save you a little bit of money. So really, this is dependent on the cost of propane and the cost of electricity. But it gives you, can give you an idea. In a lot of cases, a lot of places in California, we're seeing that it's it's a wash, or it's only a little bit more to operate your natural gas appliance. But propane tends to cost more than natural gas. And if you're in a more remote location, sometimes that pricing really goes up. So moving to an electric, especially with solar, can be cost effective or operationally worthwhile. For snow and cold climates, consider mounting your equipment up high to get it out of the snow range. There's also snow racks available that you can easily get a hold of, but it depends again on your clearances for snow. And you will want to consult with the manufacturer on your clearances for the unit itself. It's unique. They vary, it varies with each appliance, but it's possible to visually screen these if you don't like the look of it. I know on the West Coast where we are, people are getting used to seeing them, but if you're not used to having air conditioners everywhere, it can be a little jarring now to start to see the heat pumps around locations. So I do think visually screening is worth it. This is just some installs to kind of watch out for. A lot of these, most of them that we see are just really installed too close to the ground. So, and a lot of the systems aren't really paying attention to what happens with the condensate, because there is condensate that's created when these operate. So there's certain features for the cold climates for when it's freezing to keep that from not freezing up your system, but also in the shoulder seasons and in summer, they still create condensate. So you want to mitigate for that. And also another reason to get these things up off the ground is because a lot of situations where people don't realize how much their landscaping and territory in the ground moves and gets pushed by rain and snow, and their units get buried. So there's some products you can purchase off the shelf or that come with your heat pump as an accessory item, like the Pioneer makes a snow shield. But a lot of times, some of the best things we've seen is folks installing their heat pumps with a big roof. Indoor air quality is a big thing. We teach a whole class on this. So I put this in here for your information. This basic concept here for using balanced ventilation is to stop your exhaust only fan from forcing your house to leak to make up air for the exhaust only system. And just to FYI, you're not allowed to do that for multifamily projects anymore under the new code. It has to be some kind of balanced ventilation. And so what that, can look like is you could get a ERV or HRV. The ERVs are being shown now to be very effective for cold climates because they come with special control features that prevent frosting. It used to be that only HRVs were in cold climates, but now the ERVs are the ones that are being rated for cold climates. And you can go onto the HVI link. Actually, I don't think I put that one in here this time, but we can get it to you. But you go onto their website and they'll list all the products that are HVI rated. That means they'll meet California Title 24. The other thing with water heaters, thing to know is the integrated tank type water heater is very common. There's plug-in types that are 120 volt, 15 amp that are easily used as a drop-in to replace an existing gas or propane water heater. You typically need to upsize them a bit. But the main question to ask yourself is, does it freeze? So yes, if you're in a location that freezes, then you really are looking at these things should be installed inside your house. But if the temperatures don't hit freezing inside your garage, for example, and they stay above 37 degrees, then you possibly could put this in your garage, in a warm garage. So temperature range matters for these units. And that Sanco system we mentioned before, it can operate to negative 26 degrees. So sometimes this is a really good option, but it comes at a much higher cost premium. And it does, of course, require the specialized kits for freeze protection. The other ones, the integrated tank type, they're simply just not designed to be installed outdoors, and especially not in freezing temperatures. So they don't have any specialized kits. You just need to put them inside your house when you're in a cold climate is the basic thing. And then rule of thumb, the space you need for a closet for those is 2 feet 6 inches by 2 feet 6 inches. We're finding that a lot of installations of these systems are too tight. They're putting them into too small of closets with a solid door. And new to the 2025 Energy Code, in the mandatory requirements under section 110.3C7, you'll get a copy of the slide deck. It kind of goes through all the stuff that's required now for these heat pump water heaters. And it's mostly as a result of really poor installs. So give yourself more space, make your closet more generous just to make your life easier for maintenance and installation. But also there's a calculation you would need to follow for the net free ventilation area in, say, a louvered door so that this heat pump can communicate with the greater space. The model on the right, it fails, but also the unit, it's not that it just quits working, it's that it goes into electric resistance mode only, which then defeats the purpose of having a heat pump altogether. Now, when it comes to sizing these, I put this in here. This is for Rheem. It's based on your temperature of that water coming in. And so even though the chart shows California being slightly warmer than where I drew the red box, I know from folks who live in some of those cold areas of California that the water temperature is really not quite as warm as depicted on the map. So I put a red box around kind of that area, the zone. And it's within that range, really, you get, the idea is you can take a look at how many back-to-back showers you could get, assuming each shower lasts 8 minutes with a rate of 2 gallons per minute. Now, in my household, no one takes an 8-minute shower. It's like double. So, we'd get a couple showers out of it because I have a couple teenagers instead of multiple showers. So sometimes what happens is folks will opt to get a larger 80-gallon unit and go with the 30 amps just to make sure they have enough hot water. That's where I'm going with that. The plugins will operate closer to the 15 amp, but since they're only 120 volt, it's a little less than that. So they're more appropriate for really small households. This is just an example of what, this can look like. But again, warm garage, a utility room, mechanical room location is appropriate, or a closet that's sized properly. But if having the heat pump inside your small house isn't really going to work for you, then sometimes it's worth to pay that extra money to get the split system, but you'll spend twice as much on it. But then the tank itself, no moving parts, 0 clearances, you can squeeze them into what you think of as a regular closet. And then shout out again to Mammoth Lakes. They have a handout just reminding people, cold climates especially, you need to insulate all your pipes. And of course, if you have any pipes, there's a chance of freezing, then you want to include the insulation with heat tape and other ways to monitor that. And then two great resources: Northeast Energy Efficiency Partnership. That's the website that you can go to get those links to those heat pumps that are rated. You could check the box Energy Star cold climate, and then those units will come up. And then, of course, the Code Coach program under the codes and standards. You can fill out the intake form and we will get back to you with that. And then next time, we're going to have best practices for residential energy compliance for the hot climates and Cal Green. I know we're right at time. I'm happy to stay on a little bit longer if we have questions. And other than that, I'm handing it back over to Pam.
Okay, great. Thank you everyone for attending. I know we ran just a little bit over, but wanted to just remind you all that you will get these slides. There will be a survey in that email. We encourage you to please fill that out so we know for future training if we're meeting the needs. And really want to just remind you all that with CCRN, we are happy to, there's a survey here. Thank you, Jess. So if you can go ahead and fill out this survey now, that would be great. We'd appreciate that. And then just, to remind you that these, we are open for personalized trainings. We're always looking for ideas. I know this one was a little bit probably more focused on res. If there's a need for heat pumps and non-res, we certainly can provide that training as well. And then the Code Coach, just encourage you, if you ever have questions on any of the energy code, to reach out to ccrn.org and fill out that. We also have a phone number that you can call in and hopefully get your energy code questions answered. And just, our goal is to have better understanding and better compliance. We understand and acknowledge that energy code can be confusing and somewhat burdensome in the way that that it's required, but and we would love to work with the CEC to reduce some of that. So if you also have ideas or on that front, we're happy to help facilitate that conversation. But with that, we'll let you go and just look forward to our next one. Our next one is going to be completely different. And Jess, maybe you could give the details of timing and that, but it's on for hot climates.
Yes, that'll be April 21st from 9:30 to 10:30.
Great.
We do have a pile of questions. I don't know if we have an extra moment to run through these, if people want to hear some of the responses.
Yeah, if you can stay on, we certainly are happy to hang out with you.
All right, I'll try to be quick and just get people's questions answered quickly. And if any of it doesn't get quite answered to what you want, again, use the Code Coach. I'm just going to go in reverse. Jennifer, chime in. I'll tell you when some of these need your input. Kevin asks if heat pump water heaters have electric resistance elements. I said, yeah, just about all of them. Do you know of any that don't? I don't.
Yeah, there's one brand that doesn't, and I don't see folks. I just haven't really
Using
even
it.
heard of them installing it because of that
Perfect.
one feature.
So
And because of the
maybe
new
one.
part of the mandatory measures, you do have to have a backup heat source. Okay, so yeah.
Nick asked if there are energy code or mechanical code requirements for choosing to use ducting with heat pump water heaters. Like I mentioned in my comment, this is just one of the biggest topics we're dealing with. Check out a bunch of the other presentations to see about it. There isn't a requirement to duct. Oftentimes, ducting is a great solution. There are a bunch of issues associated when doing that with the install itself and in what instance you're doing it, where you're ducting it to, what the ambient temperature you're pulling it from to. There is a mandatory code requirement with the 2025 code that we're pushing as much as we can that lists out air volume required, but there isn't a code item that says, hey, you have to duct to this situation versus that situation, which is a little problematic because people are kind of just doing it how they seem to think it might work.
Right, but for the cold climates specifically, I didn't
Don't
show
duck.
any ducts because we do not recommend that you use ducts to the outside for your cold climates. Like your unit's going to turn into electric resistance mode, and you have potential of freezing up the frost, getting frost because it's so cold where these climates are. So it's all inside. And then if you want to duct from inside to inside, that's an option. And then you want to follow your manufacturer's requirements for the net free area and the size of the ducts. And it's also based on duct length.
There was a question about if code requires a specific distance for condensers outside unit from a wall, a gate, the side of the house. I don't know of any code required setback clearances. Jennifer, is there one in the mechanical code?
No, each manufacturer has
Right.
different requirements for it, but in the code, you do have to keep it 5 feet away from dryer vents because the
nice.
fine lint that comes out of the dryer vents will clog up the fins and on the heat, the coil.
There was a good little discussion about very dry air and how these units are operating with very dry air. Nathan noted that there's a D-rating chart for high altitude thin air. I think
Yes.
yeah,
Yes.
I think all
Exactly.
my
Sorry, I'm jumping right in on that one because I mentioned looking at the altitude, and I think back on this, I forgot to say, confirm with the manufacturer of that entity you're choosing for high altitude, because some, yes, are derated, but with the variable capacity, a lot of those units that are rated for cold climate, Energy Star, they've taken a lot of that into account because they're already looking at the colder climates typically being at higher elevations. But when in doubt, when you're at those really high elevations, consult the manufacturer.
My comment of that dry air is generally beneficial to the cooling mode of heat pumps, I think is kind of the basis of it. Nick and Nathan, if you guys want to discuss that in more detail, reach out to Code Coach. And then there was multiple questions from Kevin. Kevin, I guess we're just running out of time, so let me know if my answers didn't quite meet what you were looking for. That had to do with lifespan, refrigerant charge, amperage, that kind of stuff. So just reach out to Code Coach if you have follow up. Perfect. Okay. And I think that's it for today. Great questions, everyone.
Yeah, really good questions.
Cool.
Yay, thank you all for attending and
Thanks,
look forward
everyone.
to seeing you in the future.
Have a good day, all.